Now in this lesson we're going to be looking at combinations. Another way of saying combinations is unordered selections. Okay, selections made when order is not important. So, an unordered selection is called a combination. The order is not important. Consider this. Now let's say a team of 3 is to be chosen from 4 available players. Now, how many ways can this be done? Well, let the players be A, B, C and D to start with. Now if we were to draw up some sort of list, if order was important and we're choosing 3 players, let's go through it. Let's start with A firstly. It could go A, B, C, or A, B, D, or A, C, B, or A, C, D, A, D, B, or A, D, C. Okay, now looking at that, I think we've exhausted all the possibilities where A is chosen first. So we move on to B. If B was chosen first, we could have BAC, BAD, BCA, BCD, BDA, and BDC. Again, we've exhausted all the possibilities if B is chosen first. Moving on to C. If C is chosen first, we could have CAB, CAD, CBA, CBD, CDA, and CDB. Then moving on to D, DAB, DAC, DBA, DBC, DCA, and finally DCB. So if order was important, we can see all of those combinations, okay, all of those selections. There will be 24 ways of that happening. Now let's consider if order is not important, and that's the idea of combinations. Order is not important. I'll jot all those down again, but let's focus on firstly A, B, C. Now if you have a group of players where A, B and C are in the group, then we could actually say that all those other groups highlighted there, the 5 others, are exactly the same group. Alright, in each group, player A and B and C, they're all in each group. So basically, they know they don't need to be counted. Let's get rid of them. Now what about A, B, D? Again, if you have a group of players with A and B and D in it, doesn't matter what order they're chosen in, so all of those other combinations with A, B and D, get rid of them. Moving on to A, C, D. Alright, if we look at all the other groups with A and C and D in them, doesn't matter what order, get rid of those. And B, C, D, that seems to be most of them remaining. Well, it is. We can get rid of those. So just start rearranging them. Alright, tidying them up a bit. You can see that there's only 4 ways of that happening. So if order is not important, there's only 4 ways of choosing 3 people from the 4 available players. So the number of possible combinations is, okay, we can do that mathematically now, is the number of permutations divided by the number of rearrangements for each permutation. So the number of permutations we found from the first part was 24 ways. So it was 24 over the number of rearrangements for each permutation. So let's just consider, I've highlighted one permutation there, A, B, C. The way we could rearrange that, alright, there were 6 ways that altogether that could be rearranged. Hence we divided by 6. And 24 divided by 6 is 4. So that is the number of possible combinations. Now let's see, we can do this without the list. The number of possible combinations equals the number of permutations again, divided by the number of rearrangements for each permutation. So we're trying to do the same question now without the need for a list. Let's see how we go. Now there's 3 to be chosen, so we'll mark in our 3 boxes as we did with the permutations. There's 3 to be chosen. There are 4 available players. So the first selection could be any one of 4 players. The second selection, realizing we've taken 1 player already out, so there's 3 players to choose from. And then the third selection, once you've chosen 2 already, there's only 2 left. So there's 2 ways of getting that last person. Now the number of permutations, of course, remember what we do with those numbers, we multiply. 4 times 3 times 2 gives us 24. Terrific. The number of rearrangements for each permutation. Well, probably easier to consider a permutation, let's say ABC. And there's our other ways of rearranging that. So that was 3 times 2 times 1. Recall that if you have three elements, the way that you can rearrange them, 3 times 2 times 1, that gives us 6. So now doing the division, the number of possible combinations equals, well, it's the 24, we divide by 6, and we end up getting 4. Excellent. So that gives you an illustration of how you can solve that question without a diagram. Let's move that little formula up to the top there. Another example. A team of 4 players is to be chosen from a group of 7 students. In how many ways can this be done? Well, again, we're choosing 4 in this case, so we'll start off with our 4 little boxes. Now, from a group of 7 students, so that first selection can be one of 7. Any of the 7 can fit that first selection. Once we choose one, there are 6 to choose from. Once another's selected, we've got 5 to choose from. And finally, once another one's selected, we're down to 4 players to choose from. So, the number of permutations, again, simply multiplying those numbers there, end up getting 840. Now that's the number of permutations. If we have 4 players, how can they be rearranged? Well, let's consider A, B, C, D. That's a good way of doing it. The number of rearrangements for each permutation will be 4 times 3 times 2 times 1. That works out to be 24. So to answer the question now, the number of possible combinations, well, it will equal the 840 divided by the 24. So 840 divided by 24 works out to be 35.